So I am David Flynn, the CEO of Hammerspace, and I'm here today to talk principally about the concept of storageless data. And so what I want to do is answer three questions. So number one, storageless data, is that hype or real? Data gravity, our old friend. I have a new discussion point given storageless data. And the question is really fundamentally, is data gravity a bad thing or a good thing? And the third question, serverless compute. How does it relate to storageless data? What do the two things mean, and in conjunction, how is the one and the other, how do they affect each other? How are they implemented? The parallels, those things. So those are the three discussion points that I'd like to jump into. But before we do, well, let's get to number one. Before we can really get to discussion of storageless data and whether it's marketing hype, I wish I could take a vote of hands of folks who think that storageless data is just marketing hype, or those who think that it's a real thing. If we're going to get down to the bottom of that, we really need to get into what exactly is it, especially since it's a new term that the industry has started using, and there's a lot of ambiguity around it, new terms in general. But you know, if you think about it, it is a contradiction in terms. Data can't exist outside of storage. So really, what does it mean to have storageless data?
Can I jump in the discussion first? So just to be clear, I really love what you do, guys. I mean, I followed you since the beginning and primary data first. The concept of storageless looks very marketing to me. I mean, I love the virtualization stuff. I love the idea of, creating virtual volume. So call it, data abstraction somehow. But storageless is, I hate serverless as well. So that's maybe it's something that you can guess. But that's the idea. And I love serverless in the same way. I mean, I really love the concept behind it. Okay, so function as a service is something that I really love.
So thank you, by the way, for the kind words. I think fundamentally both storageless data and serverless compute, it doesn't mean that your compute tasks aren't running on servers. Ultimately, things have to run on servers, and ultimately your data has to live on storage. So, why would we make such a contradiction in terms, and what would it actually mean?
Wouldn't it be better to be called data as a service rather than storageless data?
That is one of the taglines that we have used before, but I actually think that this term has organically grown from the rest of the industry and not just from us. And what I'd like to do is maybe take a second and say that the serverless compute is really a contradiction in terms meant to emphasize the fact that we shouldn't have to care about the mapping to server, that we should be talking, especially in the DevOps and in this world of having to go scale out because Moore's law has run into a brick wall. We now have to build applications that are fundamentally scalable, which are much more complex when they have to go across multiple servers. And so at the end of the day, we have to leave behind all of the complexity and scaling all of the bounds of the infrastructure. And when you have Lambda functions, when you have microservices that are automatically orchestrated across the compute infrastructure by Kubernetes, now you don't have to care about the mapping to servers. So the term itself is meant to be a slap in the face contradiction, because what you're really saying is, I need to get my job done, I need to get my compute tasks done, I need to work with my data, but I don't want to have to care about the underlying infrastructure. I don't want to have to care about how it maps to servers. especially in the modern world where it has to map to many servers. And I don't want to have to care about how it maps to storage. So it's the emphasis of putting it to a more consumption side abstraction, tailoring to the consumer of the thing, the guy who's getting compute done, the guy who's working with data, not around the infrastructure and the infrastructure centric.
Just to pick up on what you're saying there, David, I advocate for that completely. I think the idea of a data-focused approach to storage is absolutely right. It's something I talk to customers about all of the time, because although it doesn't sound like a big shift, it sounds like just a subtle change. Actually, the change that drives in the way you start to design your data platforms, I think, is huge. So I think it's really interesting. Whether calling it storageless data is a good idea just because it stimulates debate, I'd probably go with that. I think it's a good debating point.
So this is a starting point. We still have to get very specific about exactly why is it different and how is it different. So what I'd like to do is to actually diagram that as we go here. And it really starts with the fact that just like on the compute side, we're having to do scale out, right? Because of the end of Moore's law, to build scalable applications, they have to run across many services. So we go to microservices and container orchestration to make that manageable from a complexity perspective. In that same sense, in the data world and in the compute world, we have to go to more than one data center. And that's really the driving function behind all of this, is how do we operate in a world where things need to run on different clouds, on-prem and in cloud, i.e. hybrid cloud, multi-cloud, and even more so now with edge computing and that. So it really starts with, we have our corporate data centers, we have our public clouds, we have our edge sites, our POPs. We need to have our services available to all of those, and they need to have data. The first premise is we have to have the agent which creates storageless data be able to run on all of that infrastructure. It needs to run on virtual, it needs to run on bare metal physical, it needs to run in containers. It has to be universally available if we're going to present data to all of them. So that's first and foremost, is it has to be software, and it can't be bound to specific hardware. It can't be a hardware solution because it has to live in all of these places. And the only way that's going to happen is if you can spin it up on commodity infrastructure, on any of the models. It has to be able to come out of the cloud, preferably right out of their marketplace. You shouldn't have to do anything special to get it running. But what does it do? First thing, it needs to be able to take all of your storage infrastructure, whether they be the most primitive of direct attached flash and disk in the servers themselves, whether it's storage area networks, block arrays, whether it's network attached storage with file-based or object stores, or the cloud services, and the many of them. I think Amazon has like 14 different storage services of these different types that are block, file, and object, whether it's instance store or the elastic block service or elastic file service or S3 or Glacier, S3 inactive. There are tons of these, and they're all islands in and of themselves. So the first thing, number one premise of storageless data, if I were to define it, is you have to be able to be a global storage manager. Put all of those under one pane of glass and under one resource allocator that understands the different capabilities, the different design points, the different locations where these are present. So number one, global storage manager. By the way, it has to be multi-vendor, it has to be multi-protocol. This is why traditional storage guys can't just take their storage system and say, oh, we're storageless data now. This is about embracing the complexity, the same way Kubernetes embraces the diversity of the server infrastructure so that it can hide it from you. The whole point of doing this is so that it doesn't have to be done one-off individually with each of them. But what good does this do?
Hey, David, I mean, the challenge here is that, spanning the data centers, all three public clouds and all the edge sites in the world is not possible, right? And then even, spanning server DAS, SAN, NAS, object and cloud storage in the same framework, in the same environment, or the same solution seems impossible as well.
So you have hit on the number two concern. Number one is, what is it and why do I care? Storageless data. I think you guys being in the industry know where we're going and why it would be valuable. But number two is, okay, fine, but what you're talking about is impossible. It's way too complex, too good to be true. We're going to demonstrate it to you today. We do this today. I'm telling you that we do all of this today, everything I'm presenting to you. So I hear you, your concern, because this is a monumental lift. And this is something that has taken many years, basically since I left Fusion.io. When I left Fusion.io, it was a realization this was the seminal problem in our industry and that this is what was needed. And this has been a long journey with a lot of very talented people investing over 500,000 man hours of R&D. This is not a lightweight thing, which is why you can't have a Johnny come lately who says, "Oh, my storage system, I'm now storageless." It's not even on the same planet in terms of what it does. But let's see, before we go there, we're not done yet, because just being a single pane of glass and embracing all of the diversity here isn't it. What you have to do next is put something on top of it that can give you the view of your data, a metadata service that presents you your data. We don't actually work with data generally as humans. We're working with the metadata, the name of the file, the access controls. What we were really thinking about as the data is actually its description, how we call it, its handle. That's the metadata. So storageless data presumes a metadata service that can give you the view of your data independent of all of that infrastructure. Number two is direct data routing. It has to be able to direct access to the data and make data into a routed resource, not proxied, very different, that would kill your performance, but a routed resource for direct access. And last, it has to be able to orchestrate the data across the environment, moving data from whatever piece of storage to another, maintaining even multiple copies of the same data item across those. So this is the main thing that so far.
So David,
storage, putting the layer top. Yep.
Yeah, so Dave, so without sounding like a Hammerspace fanboy, because that doesn't really work at Field Day, does it?
We like skeptics better because it makes more.
Yeah, I know. And I suppose I'm struggling to be a skeptic at the moment, because I think all of the things that you're talking about here are crucial to the conversation that we're having all of the time now. It's about consistency across multiple platforms, across multiple repositories, the ability to have something that can understand all of that, orchestrate and automate movement of data.
That's right.
Are all critical things. I'll probably go back to what Ray said there, that it's about shows how this is done. I think the concept is absolutely right. And if we want to use storageless to drive the conversation, to drive this kind of thinking, then I'm kind of okay with that, as much as Enrico hates the phrase. So yeah, I mean, for me, I think this is a crucial part of modern data platform design.
Really agree. And all of this stuff here is actually in service of one goal. And that's what we get to now. It's being able to present data with a universal data provider, so that the consumers of data, your applications and your users, can have a global view across data center, a consistent view, a continuous access view. They don't have to take downtime and can sit there and consume and generate data into the environment without interruption and without having to care about where the data resides or even when it moves, so that you can separate the positioning of the data, the presence of the data on the infrastructure, and the management of the infrastructure, separate that out entirely, so that the users, the DevOps team, developers, the researchers can simply work with data and be self-service. So that is our goal. is to elevate it to a higher level abstraction where your consumers are much more proficient because they don't have to worry about sending a ticket to IT and asking for data sets to be moved and asking for their peer on the other side of the world to be able to get access to it and run his stuff on it. Okay, this is all fine, but here's the rub. You have to be able to do all of this without killing the benefits of the infrastructure. You can't come in and compromise performance and kill your reliability, damage the cost structure behind it, or make it an even worse management nightmare. And attempts in the past of achieving this have not gone far enough to get to the far side where it is simpler to manage and where you can actually use the technology to improve the capabilities of the infrastructure. So let me stop. One last thing on this slide. I want you to take away from this 3 things. These are the 3 basic principles of storageless data. 1 is global storage manager. 2 is the middle layer with metadata service, direct routing, and the orchestration. Let's talk about that as the orchestration and presentation layer. And number 3 is universal data provider. It has to be able to provide data across different data centers, active, maybe eventually consistent, but active, across all different protocols. And those are the 3 basic principles. As an advanced principle, you have to be able to do that, not only without killing performance, the data protection capabilities and the cost structure, but you have to be able to dramatically improve the capabilities of the underlying infrastructure by utilizing that ability to do orchestration and direct routing. So it is possible. To actually get higher performance because now you have truly parallel scalable access. It is possible to actually get better performance in your metadata because now it is a dedicated scalable service that isn't hindered by having to ship all of the data back and forth. It is possible to get better performance because it's directly routing to the exact same server that the application is running on without even having to go over the network. So moving to an orchestrated direct routing separate metadata service actually allows you to unlock scale and performance that you weren't able to achieve before with infrastructure. The same can be said about data protection. First, the system that is providing storageless data itself has to be much more robust than even the most robust storage infrastructure. Much more redundancy, much more capable. That's a high bar. It's achievable. And that's what we've done in having multiple levels of redundancy in the Hammerspace metadata service and orchestration service itself. We understand that we're asking our users to trust us the same as they would a storage vendor, or maybe even more so because this becomes an even more critical piece of the infrastructure. That's a high bar to be met. Once you meet that bar, it's beautiful though that you can actually enhance the reliability of data because I can maintain multiple copies across multiple independent storage systems. I can put it in a system in the cloud, and you can actually get better data protection, better data redundancy through this principle of orchestrating data and having a metadata service that is responsible for making the data redundant and recoverable.
Yeah, so the challenge is, higher performance at scale. NVMe over Fabric, we're talking 100 microseconds types of response time. And if you introduce, a metadata server and a direct data router and an orchestration solution to some of this stuff, how does this, I don't know how this works.
So we can actually get higher performance than NVMe over Fabric because once you open the file or once you connect to the container, the route is handed to the client, which is now built into Linux, and it will access it directly on the same box. So you don't even have to go over the network. You don't have to ship it, even if it is an RDMA network. It's actually faster and much higher bandwidth to have it on the PCI Express bus. This goes back to my beloved Fusion IO and the introduction of server-attached flash. I came from the world doing supercomputers and introduced InfiniBand in the supercomputing world. And it was that in work with InfiniBand and high-performance RDMA networks that led me to realize flash could be much faster than the legacy SSDs of the past. And that's what led to NVMe. But as I was working with those concepts, I realized that better yet, don't go over the network at all. Or if you do, just for one redundant write, but have all of the reads stay local and have the access local where you can get potentially hundreds of gigabytes per second of bandwidth, tens of millions of IOPS, and very low level latency. Making data direct routed resources, you can do that. Okay, let me draw the parallel here. In the world of, and I hate to go back to this, Hadoop, you had, each server had its own storage and you could get very high bandwidth with it. All right, now, by keeping the data on the node that's using it, you have huge benefits. Always stretching it across, even an RDMA fabric has detriment. This allows you to get that direct access when the data is affinitized and when it's been orchestrated to the same node. When it's on a different node, then you can use RDMA, and we support RDMA access as well. So you get that RDMA fabric. Okay, maybe a little less controversial, and I'd love to take up when we have time for a deeper discussion, that performance thing and do some fun stuff on it. I think it's evident to everybody that if you put all of this under a single pane of glass and globally manage your storage infrastructure resources, you can make it so this takes a lot less time to manage it. You can also reduce the cost in a myriad of ways by being able to use the newest, fastest, cheapest, and easily move to it, by being able to exploit the old and existing for much longer. You already have a sunk cost investment. It's kind of a contradiction in terms here to say that I'm building a system that makes data easily to move around, and the net result is I keep using my old infrastructure for longer. But that's a very important aspect, is that I can take my on-prem existing infrastructure and run it into the ground, because now I can create redundant copies and I can move off of it at a moment's notice without interrupting my users, so you can get better utility from it. So as if the bar weren't high enough, being able to be a global storage manager, to do that in a way that augments performance, augments protection, makes it easier to manage a complex infrastructure world, and lowers the overall costs. I think we're seeing this on the compute side with Kubernetes, making these kinds of things possible. And it really goes to the architectural design. The fifth and last, remember we have 5 tenets: global storage manager, universal data provider, the data orchestration layer, and to be able to improve the infrastructure capabilities, not mask them. Last one is to make it possible for the users of the data to be self-service. They don't need to get help with managing their data. They need to be able to get their data services, their data protection, and so forth without having to go to IT, without having to become an expert. Having ubiquitous access across different sites, across different protocols with high performance, and those advanced data services. So this is what I'd say are the 5 tenets of storageless data. I wish I could boil it down to something simpler than that, but basically we're creating an abstraction, and what it does on the underside, what it does for the upper side, And those are the main pieces to it.
There's lots of constraints that Kubernetes puts on. Yeah, Kubernetes brings a lot of functionality and capability to the world, but in order to be able to use it, you have to have a different mindset. You have to refactor your applications of microservices. You have to create a mesh environment. You have to create all these YAML files. All this stuff has to be done in order to be able to take advantage of what Kubernetes is providing. So what is this, this sort of solution that you're bringing here is a different mindset. It's a different environment. Yeah, I think it can work, but what does this mean to the storage users or the applications that are out there, or the world that we know and exists today?
First, we're supporting the existing universe of protocols so that applications and users don't have to think of it different. I would argue that object storage begs that people rewrite their application to do their own tiering, their own data management, because object storage is very high latency. And object storage means basically rewriting to use RESTful interfaces. If people have done that, that's great. But we're making it possible for them to use traditional block and file interfaces to their data without having to rewrite it. But what does change is the quality of how you manage the mapping of data to the storage. Where it was done in the imperative through setting up and copying data or setting up replication links, all of those things, in our world, it becomes declarative. And this is the first way that storageless data parallels with a similar architectural approach, serverless compute. It uses a declarative model. You mentioned the lovely YAML files in the Kubernetes world. In our world, you have objectives, and those objectives can be placed on the data in your file system / object store. If you had to do that on individual files, it would be a nightmare. What you're able to do in our world is they're inherited, and they can be pattern-based with business logic or formulas that can say these types of data under this circumstance need this from their infrastructure. It needs this level of performance. It needs this level of protection. It needs to be redundant across sites. Those statements of intent are made to be both very concrete. If you want to manage it using the old world, you can just say, put this data right here on this storage. And you can put an objective that says, put it here and put it here. So you can manage using the old world of doing it. But now it's the swipe of a mouse and the system will move it without interruption. So we're trying to allow for the old paradigm of manually saying this goes here and this whole data set goes here and this whole data set goes here, to where as an admin, you can still manage your data that way, but you don't have to actually carry out the manual tasks to make it happen.
So the one thing that, the server environment has going for it is that, applications can scale through replication. Yeah, I can take the same set of microservices and replicate them 1,000 times to have 1,000 times the performance. Data doesn't necessarily scale with just replication. I mean, each of those applications are going to be dealing with a different, microservices are going to be dealing, or replications of microservices is going to be dealing with different data.
That's exactly right. But the data about the data that describes how that data needs to behave across the world of infrastructure is itself a repeatable thing. And that's what I'm saying, is that by using the declarative model, you can declare the rules by which things should behave just once. And now if I have umpteen different applications with their own containers, have different data sets for my drug researchers, you can describe in shorthand which data needs what type of presence on the infrastructure.
All right, thanks.
But quick question based on that. So what are the examples of, like, what do you declare about that data? Is it the performance requirements, the access requirements? What does that look like?
Yeah, that's excellent. So the service level objectives, and this Service level objectives can be very concrete. Let's take a step back. Anything and everything that ever goes into deciding where should my data be placed, what storage should house my data, whether it's concerns about performance level, how high availability, how durable it is, how cheap it is, GDPR, whether it's allowed to be in this country or that country, or whether I have to keep the data sovereign, whether I need to keep it on a storage array that's owned by the same department, ownership. Basically, anything and everything that ever went into the calculus of where should we as an organization house this piece of data at this point in its lifetime, those are turned into statements of objectives. And so those objectives can be across the spectrum, from very concrete of saying, hey, put this data set or this data item or this directory, anything that you can put a filter around, you can bundle and say, this goes right here. And you can do it in the very concrete fashion of saying this specific storage system, or more generally, one of these storage systems. And you can put very specific placement rules. Put it here, don't allow it to be anywhere over here. And to the extent there are degrees of freedom, the orchestration system will make choices to do load balancing, to do performance balancing, to get optimal utilization of the resources. So we start with do no harm, at least be as specific as it was before. So if somebody wants to manage their data environment, by manually saying this file system here, this file system here, this here, they can do that. At least in our world, they can change their mind and it not be like a major take an outage and have to reconfigure your users and all of that, because now you just switch the objective. And by the way, it moves the data in the background. Nobody knows the difference. They're still using it. They're still generating more data. So on one extreme, they're very, very specific. On the other extreme, they're abstract. They're things like, I need this performance level. I need this kind of protection. I need disaster recovery capabilities, or I need it recovered over on this site. And these things can be blended at different levels. You can use statements of both. Now, here's the fascinating thing. Service level objectives turn out to be very similar to access controls in a file system. Access controls are gating who has access to do what with the data. Service level objectives are stating on the back end of the data, what are the constraints about where that data needs to reside in the universe of infrastructure. So service level objectives are very much like access controls, only much more powerful because they can use filter statements, they can have business logic, and they can be applied conditionally using that, and they can be very specific or they can be very abstract. By the way, that's not unlike access controls where they can be abstract or where they can be specific or general. For example, you can say this group of users has access or this specific user has access. We can say this group of storage systems is a viable place to put it, or this specific one is the place I want it put. So ACLs and service level objectives are really flip sides of the same coin. And when you elevate the data out of the infrastructure, that's what you put in is the bottom side that has the constraints about the data's ability to exist in the universe. Because what we're really doing here is we're empowering data to be self-managing through metadata.
Encryption. How do you deal with data that's encrypted and moving it back and forth? I mean, to some extent, you're kind of avoiding the data path as much as you can to be managing the control path and all this. But at some point, if you're going to be moving data back and forth, you have to have data movers.
That's exactly right. The data orchestration, we have data movers that move data in and out of object storage. We have data movers that move it between file storage. You're absolutely right. Data movers are a big part of that. And we operate with the encryption at rest and the encryption in flight of these existing storage systems. But let me give you one example, a case in point. We have a customer who's a law firm. Law firms are extremely anal retentive about subpoenas and discovery of data. And so they don't put their data in the cloud using just the encryption that is provided by the cloud, because a government could subpoena the cloud provider and say, give me access to this law firm's bucket. And because they're in physical possession of the data and the keys, the cloud provider would have no choice but to open it up, and voila, government now has access legally through a subpoena to all of that. Now, this law firm needs a ransomware recovery scheme. What better than to put it on the cloud? But to do that, they need to maintain all of the data encrypted using their own key manager and their own keys. Hammerspace becomes the agent to orchestrate a replica of their existing file environment into the cloud, and do so using another layer of encryption at the storageless data layer that interacts with their key manager. So not only do we interact with the existing encryption in flight and at rest, but we are able to add an additional layer that can protect you against the cloud itself, even though they have their own encryption.